So hello class, let us look at some review questions. So I gave you a triangle here. A is negative 4 comma 4, B is 4 comma 2 as you can see, and C is negative 4 comma negative 2. Now one of the students asked if we can find an equations of an altitude and maybe finding an intersection as well. So let's try to do this one first. So then we have three sides and then three vertices, so we should be able to find the three altitudes. In this case, we're going to actually find all three altitudes and then try to find the intersections, and then hopefully we will see that they are equal, same intersections no matter which lines we pick. So first one, I'm going to go from point A. Now I'm going to try to have the altitude coming down this way somehow. But since A is negative 4 comma 4, I just need to find the slope. Slope that I'm looking for is BC, the opposite side here. What is the slope then? 2 minus negative 2 over 4 minus negative 4. Now, then we get to realize that it becomes 4 over 8. We realize that the slope is 1/2. That means slope that I'm looking for perpendicular to that would have been negative reciprocal of 1/2, which is negative 2. Now, given this one, we should be able to find the equation of that, which is y minus 4 equals negative 2 x plus 4. That is the equation of the altitude from A. Now, let's try to do from B. Now, B is 4 comma 2. But as you can see, after you plot the points, you will realize that the side opposite from B is AC. And you can see that AC is vertical like this. That means what do you realize about this perpendicular line? It would have been horizontal like this. So that means I can try to find the slope and negative reciprocal, but since in this case I can clearly see that the blue line has to be horizontal while yellow is the vertical, that means my equation will be y equals k. Now, what is the k value? That's equal to 2. So I know that equation for this one will be y equals 2. So that is my equation of the altitude from B. And this one was the equation of the altitude from A. Now let's try to go for the third one, which is from C, which is equal to negative 4 comma negative 2. Now, then we need to find the slope of AB. Then here we get 2 minus 4, and then 4 minus negative 4, which becomes negative 2 on top and 8 on the bottom. So we realize the slope is equal to negative 1/4. Then what does that mean? Slope that we are looking at is equal to 4. So using 4 and then this point, we should be able to figure out the equation, which is y plus 2 equals 4 times x plus 4. So that is our equation. Now, then let's try to find the intersection here. What I'm going to do is, since this one is the simplest, I'm going to connect these two and then find the intersection. So then to do that, I just have to put 2 in place of y. So we get 2 minus 4, which is equal to negative 2 times x plus 4. Now then let us try to calculate this one. Left side becomes negative 2, which is equal to negative 2x plus 4 with the parentheses. I'm going to divide by negative 2. Then we get x plus 4 must be equal to 1. Then x must be equal to negative 3. So we realize that point of intersection of the altitude is 2 comma negative 3. Or I mean negative 3 comma 2 is our uh, intersection of altitude. Now, but that was between first and the second one. What if I were to go for the second and third one? I should be able to get the same answer. So I'm going to put 2 in place of y here once again. Then I'll be getting 2 plus 2, which is equal to 4 times x plus 4. Now my left side becomes 4 equals 4 x plus 4. Divide by 4, we end up getting x plus 4 is equal to 1. Now, then x must be equal to negative 3. So as you can see, once again, we realize that negative 3 is the x value, y value was equal to 2. And that becomes our answer. Now, so this one was only the first question based upon altitude. Now, another thing is we want to try to look at the perpendicular bisectors. So let's try to look at this question, but instead of altitudes, let's try to go for the perpendicular bisectors. So I'm gonna first start from A. Then perpendicular bisector, the word bisector implies the midpoint. So we need to find the midpoint opposite from A, which is B and C. So midpoint of BC. Then I'll be doing adding x values and divide by 2, adding y values and divide by 2. So we get 4 plus negative 4 divided by 2, and then 2 plus negative 2 divided by 2. In this case, happened to be that it was 0, 0. Now, the next one is we need to find the slope of BC and then find the perpendicular slope of the perpendicular line to that. The slope of BC would have been equal to, since we kind of calculated that already in the previous one, I'm just going to borrow that it was 1/2. So then, slope of the line that's perpendicular to that would have been negative 2. So our equation of the perpendicular bisector in this case would have been y minus 0, which is equal to negative 2, and x minus 0, which we can easily see that y equals negative 2x. That's the first one. How about the second one? Let us try to go from B. Then I need to find the midpoint of AC. You can even visually see that midpoint of AC is, I have 1, 2, 3, 4, 5, 6 units. So I'm going to go halfway, 1, 2, 3. This must be my midpoint. I can use the midpoint formula, or I can just graphically count it here as well. Either way would be fine, which is negative 4, 1. So let us say that the midpoint is negative 4, 1. Now, but in this case, perpendicular line to the vertical line would be horizontal line, as we mentioned on the previous part of this video. So then we get to see that, all right, then what is the horizontal line that passes through 1? Because horizontal line would be y equals k. So in this case, y equals 1 will be the equation of the perpendicular bisector of that line. All right, now let's go for the third one. From C. Perpendicular line opposite from C. That means I need to figure out AB as well here. Midpoint of AB is simply negative 4 plus 4. Okay, so here we get negative 4 plus 4 over 2, and then 4 plus 2 over 2. We get to realize that 0, 3 becomes our midpoint. Now, then let's try to go for the slope. Slope of AB, I believe we calculated that earlier, which was negative 1/4. That means slope of the line that's perpendicular to that would have been simply 4. Then our equation for the perpendicular bisector would be y minus 3, which is equal to 4 and x minus 0. Then you can simplify this one as y equals 4x plus 3 quite nicely. So then, since we have 3 equations here, first, second, and then third, let us try to find the intersection of that. So first one here, it becomes, all right, since y equals 1, then in this case, this one will tell you 1 equals negative 2x. Then x becomes negative 1/2. Not bad at all. So here we get negative 1/2 as our x value, and the y value was 1. So then our circumcenter in this case, because perpendicular bisectors, would be negative 1/2, 1 would be the answer. Now, but if you have to try to use this given equation, y equals 1, with this one, let us try to see what we end up getting. Then, y value was equal to, once again, 1 equals 4x plus 3, and subtracting 3 from each side. Then we get negative 2 equals 4x. Divide by 4, then x equals negative 1/2 as well. And same answer as this one. So whether we find the intersection by 2 lines or 3 lines, it shouldn't matter. All right. Now, another question that was given was different types of equation. Basically, we talked about 3 types of equations. One is the slope, y-intercept, and then slope, point, and standard. So now, let us try to give you 2 points, for example. Let us say 2, 3 is given, and the other point is negative 1, 10 is given. Then how do you find the equation in each given ways? So first thing which we can do is find the slope, because it involves both of them anyway. So slope here is equal to 10 minus 3 over negative 1 minus 2. Then we get top is 7, bottom is negative 3. So we realize the slope is negative 7 over 3. Then in this case, using this, I can find this one quite easily. Point slope would have been y minus, I can use any one of those 2 points. I'm going to use this one since it seems to be easier. Y minus 3 is equal to negative 7 over 3 x minus 2. That should be my equation. But based upon the slope y-intercept form, this one will tell me y equals negative 7 over 3x, but I don't know what y-intercept is. So in this case, what I'm going to do is I'm going to use one of these 2 points to plot in place of x and y to find the value of b. So I'm just going to use this one because it's a smaller number, so I'll be getting 3 equals negative 7 over 3 times 2 plus b. Now, then here, I'll be getting 3 is equal to negative 14 over 3 plus b. By adding 3 over 14 from both sides to have b by itself, Then 3 is 9 over 3, so we get 23 over 3 becomes our answer. So here we get, combining these things, y equals negative 7 over 3x plus 23 over 3. Now, either way, how can we figure out the standard equation? Now, in fact, one of the way which we can do this, I'm going to convert each equation to standard form, and then hopefully we should be able to get the same answer. So to do that, first one, I'm going to multiply everything by 3. Then, so even though this is a slope y-intercept form, in order for me to convert this one to the standard form, I'm going to multiply everything by 3. So we get 3y, which is equal to negative 7x from here, plus 23. Then I can add 7x in both cases. So we get 7x plus 3y is equal to 23. So this is how I can convert that into standard form. Or I can write it in this way, or I can bring 23 onto the other side and set it equal to 0. Either way would be fine. So we get 7x plus 3y minus 23 equal to 0. Either way would have been okay. Now, but if I were to use the second slope point form, in order for me to do that, I have one fraction, so I'm going to get rid of denominator by multiplying everything by 3. Then I'll be getting 3y minus 9 is equal to negative 7x minus 2 with the parentheses. That's what I will be getting after multiplying everything by 3. And then, by distributing negative 7, we get 3y minus 9, which is equal to negative 7x plus 14. So by adding 9 and adding 7x, we get 7x plus 3y equals 23. And we see that it's exactly the same thing over here. All right, so that's what basically that's what we could have done. All right, guys, so let us look at the next question. Different way besides that this. So basically, if you wanna find the length of the line segment, not a line but line segment, what you can do is you can just use the Pythagorean Theorem. That's another way besides using the distance formula. But essentially, they're the same thing because distance formula came from the Pythagorean Theorem. So if I were to just pick any 2 points here, randomly picked 2 points. So I'm trying to find that length. So let's call this one as A. Let's call this one as B. Point A is negative 5, negative 1. Point B is 5, 3. Then what I can do is I can count horizontal differences and vertical differences. You can do that with the ruler, of course. Now, then I see that vertical difference is easier to count. It's 4 units. Horizontal difference seems to be 1, 2, 3, 4, 5, because it was from negative 5. Going 1, 2, 3, 4, 5. Okay, because it was 5, so totally it becomes 10. Then our distance becomes the hypotenuse of the right triangle that I'm looking at. So I'm going to call that as D. Then we get to see 4 squared plus 10 squared must be equal to D squared. Then here we get 16 plus 100 equals D squared. Then we get to realize that D must be equal to square root of 116. But you know that 116 is in fact divisible by 4. So we get 4 times 29, I believe, is equal to D, so which is equal to 2 square root of 29. So that's another way for you to find the length of the line segment, besides using the distance formula, in fact, even though this was the distance formula anyway. All right, so next question by same student. It says, can we try to, basically in this case, I'm assuming that if we can try to cut a line segment in a ratio and then finding the particular point. So I'm going to assume that point C is on line segment AB and between A and B. So now, if the ratio of AC to CB is equal to, let us say, 3 to 5, as an example. Just randomly pick those two ratios, and then assume that point A is -2, 5, and point B is equal to 6, -11, as an example. So now what we want to do is we want to find C. Now then what we can do is graphically, we'll try to do this one graphically first. So now we're going to plot those 2 points, -2 and 5. 2, 4, 5. That's A. And B was 6, -11. In fact, I believe this one only goes down 2. So why don't I try to redo this one. I'm going to bring this one up a little bit. That means point A has to be -2, 5. So it should be around here. Okay, now then I can plot the other point. 6, -11. So here we get 2, 4, 6, -11. So 2, 4, 6, 8, 10, and 11. So that's B. Now I'm gonna connect those two dots, and I'm gonna go for the horizontal differences and vertical differences just like before, as if I'm finding the distances. I mean the distance between A and B. What I'm going to do is I'm gonna all right. Now, but in this case, it seems to be that the horizontal difference is smaller, and hopefully, I'm hoping that it'll be easier for me to deal with this one. So here, horizontal difference is 2, 4, 6, 8. Total 8 units. That means, but it has to be broken down to 3 to 5 ratio. So I'm going to write it as, I don't know where it is, but I'm going to say 3A plus 5A, because that ratio total add up to 8. That means in this case, you can easily see that A is equal to 8, so A must be equal to 1. So 1 is one portion in this case. But I'm looking at from A, I can go for 3 portions to C. So 3 portions in this case, meaning 1, 2, 3. Because that's where how many, 3 number of A's will be located at. So then once I have this one, what I can do is I can go towards the line segment that's passing by. So if I were to keep on going, you can see that I will meet up right over here. Then in this case, in fact, you will realize that that point was 1, -1. And that must be our value or coordinate of C. Now, so we have done it graphically, but how else would you be able to do this one? Or what if you were to do this one algebraically? So then I will be doing them over here. To find the x values. Of course, there are more than one way for us to do it, but we're just going to do it this way for now. To find the x value, we need to find the difference in x values. I'm going to try to do this one by b minus a. That means I'm counting from a towards b. B minus a, that means we get 6 minus -2, which is equal to 8, as you can see. And then that 8 must be in the ratio of 3 to 5. So I'm going to do 3a plus 5a, just like before, which is equal to 8. Then you can see that a was equal to 1. That means, how do you find the x value of the C point? I'm coming from a value here, which is negative 2 plus. Since the ratio was 3 portions of a, which is equal to 1, then that's my x value. What's my y value then? To find the y value, what I can do is consider the change of y, which is equal to, I'm going to go from b minus a once again, then negative 11 minus 5, which is equal to negative 16. So then I'm going to do that one more time. In this case, not 3a, but rather 3b, because the portions are not necessarily the same between horizontal and vertical. So 3b plus 5b must be equal to negative 16. And you can easily see that b must be equal to negative 2. Then our y value starts from a, which is equal to 5. And because I'm starting from a, I have to go for 3 units of this b value. So 3 units of this b value. Once I calculate this one, on my x value becomes 1, and on my y value is negative 1. 5 plus negative 6, which is exactly the same thing as what we found graphically earlier. All right, so that was the next question. All right, and I guess that was it. And somebody asked me, how do you study? Make sure, as I mentioned it a few times in class, make sure you understand all the homework questions and notes. And if you're done with it, then you can just try to make up some more questions and enjoy studying. I'll see you later. Bye-bye.